Hello, everyone. Thanks for coming. I'm Ederson de Souza. I'm a software engineer at Intel for some time already, and in the last 2.5 years, I've been working with Zephyr. And this morning, we'll be talking about, I'll be talking about, or you'll be talking about, the future of Zephyr device module. This is the agenda. Talk about current interest, what is the device module, and some topics, assorted topics about the future of device model. A disclaimer, I'm no oracle, no seer, so it's not like I'm seeing this from the future and I'll be presenting to you. It's actually being built, I'm helping, and I need your feedback, actually. So this is to start getting some ideas, some use cases, some constraints. I have some code that I kind of prototyped for some of those topics, and I will need your feedback to evolve that. What is the device model? Well, basically it's how Zephyr model devices. So the life cycle, how do we define their APIs, how they connect, how devices work on Zephyr, how do we manage them? And in this slide, you can see a collage of some assorted issues and pull requests relating to the device model. A parenthesis here, I wanted to have like a nice collage with newspaper headlines, but I'm no artist, I'm no designer, so okay, let me ask some of this AI stuff to do it for me. And why it created something that reminded the collage, the text was like alien, it's gibberish, you cannot create something with real text, so we have to resort to the software developer trying to be an artist here, so sorry for the not so beautiful collage. And some of the topics in there are related to how do we, the life cycle of the device, how we initialize them. Maybe we don't want to initialize them at boot as Zephyr has always been done. Some people want to extend the API, so you can like have new API on top of something instead of like having to create a totally new API for some specific device, and more. Actually, there are some of those issues are actually wish lists, so there are many things. And I want feedback, so please talk. Of course, it will be at the end, so I'll try to go fast to give some few minutes or several minutes to get feedback. Although the talk is about the future, the first topic is actually about the past, because last week the deferred initialization was merged. What is that? So far, Zephyr had been initializing all devices on boot before the main function of your application starts to run. And in some cases, you don't want that. For some reason, maybe you have some device that won't be there, or won't be needed for some specific use, and well, they would be initialized. There was an issue for that, probably is one of those on the collage, and there was a lengthy discussion, started like in 2021, I think, yeah. And it was a really fruitful one. There's people come up with some ideas, they decided on one, try to implement that. When they implemented, they saw that wasn't that good, then try to implement another one. And finally, it was merged last week, and it's a really, really simple one. You just notate on your device that on the device tree that's going to be deferred, and Zephyr will skip it during boot. So it won't be even checking. It use some linker trickery to separate the initialization of the code that initializes that device in a separate section, so it's kind of no overhead there. And then, of course, you want to initialize it later, so there's a new API that you can use to initialize the device. But this is about the past, but there's a lesson learned here. During the implementation of this, there was a detour. Some ideas appeared, a new pull request was created. It seems nice that there was some really nice features there, but there were a disconnect with the issue. So people that were discussing the issue were not on this second pull request, and so we kind of lost some institutional information about the issue. After some time, we got back there, we could get in touch with the people. So the lesson here is, if your pull request starts to deviate a bit from the issue that was supposed to be fixing, try to get the people from the issue on your pull request, because otherwise you may lose some information and something completely different than was agreed will be merged. Talking about the near future. Why I call this near future? Because I have a pull request as a work in progress that touch some of this area, and maybe we'll start the discussion for this now. This is about the initialization order. So not only we want to initialize the device, but there's an order that we want to respect. This order basically comes from the device tree, but not only. We also have a priority that we can set for the devices, for the drivers when they are initialized, so that you can ensure that like some function that initializes some registers runs before you try to initialize the GPIO or some other hardware that you want to initialize. And this other function is, we use the sysinit macro to define a function that will be called at some point during the initialization. This point is defined by a priority again. This priority is basically a number that the smaller number will run faster, will run before first. And then you kind of have to tweak those numbers with the priority of the GPIO, for instance, plus the sysinit to get things done in order. And this is bad because those numbers don't track the dependencies. They are just numbers that you can tweak to get what you want. But if you change something in the future, or a new device you will need maybe to change all the numbers before and after to get there. So not ideal. I have sent some pull requests to fix some of those issues. So we don't want that. How does that work now? Inside Zephyr is basically we have the init entries. That's a section inside the file. It's divided by levels. So we have like the pre-kernel, pre-kernel 2, post-kernel. And inside of each of those levels, we sort, like with linker script trickery, the sections. So every sysinit or the device init, device tree init function have a name that takes like the level, the priority, and sub-priority, and then we sort this. So we can have like, so that's how the order is defined, then Zephyr will be looping over those init entries and initialize them. The init entry is basically a pointer, to a device, and a function that will be called. If it's just a sysinit, it's just a function. You can check the order using westbuild-t init levels. It's helpful to debug. And here there's something, I'm not sure if you can see, interesting. This is from a real build. So I was getting the data there and trying to create this diagram. And note that the pre-kernel 140 and pre-kernel 140. So both the ECIA and the SOC inits have the same priority. But the SOC needs to go after because like it's an underscore, the next one is lexicographical order. If it was 000, it would be the other way. Suspicious. So how can we tackle that? Proposal, and this is the very first one, so I'm hoping to iterate that, is let's use the names. Which names? For the functions, for the sysinit functions, we can basically use their names. For the devices that you want like to be initialized before or after, right now I'm using the compatible because it's a name that's already there. Maybe it's not the best name. Maybe we should have like instead of using the compatible, we could use like just GPIO. But then we would have to name the devices like this is GPIO, this is UART, this is UART early because it's another UART that you want to use on a different moment. So this macro basically defines the function that we're going to call. The first argument is like a semicolon separated list of all things, devices, and functions that you want this to run before. And the second is the ones that you want to run after. So if you go back, I want this SOC init to run before GPIO and after the ECIA. This is defined on code, but we need a way to override it. And I'm not sure a good way to override it. We could have like a separate file, but usually we don't want separate more files on Zephyr, so I decided to use the kconfig, but maybe this is abusing the kconfig. But basically in this initial prototype, you can name, you can aptly name your config that then will be looked to override the definitions on code. And being a kconfig, you could also use the prjconf. Maybe some of you noticed that I use serves as the name for the serves. And I've been told that this is old, Zephyr is more mature now, we don't want those jokes with Z or Z. So there's a small parenthesis here. I want to ask a question. Who thinks that Zephyr now is like more mature, doesn't need to have things starting with Z? And who thinks that Z is too cool? Okay, thank you. So how it becomes, basically. All that information, now we have a two-step build. This is kind of mandatory. The first step build, we just build it as is right now because we want to integrate with Qt functionalities. We don't want to change the world. I mean, Zephyr doesn't shy away from changing everything from time to time, but let's try to avoid that. So to be compatible with what we have right now, we would build it. So every sysinit and device tree entry will be then read from the elf file, so we can see what is the current order. This is added on a topological list with the constraints like this comes before the other one. We then read the elf file again to read the service entries, the kconfig. We place this in this list, and then we sort it. This is done by a script, Python 1. So after this, we have like a topologically sorted list of entries. And we use that list of entries to create a linker script snippet that will be used to generate the order. So now the SOC init is properly after the CIA. I'm not sure if that's the right order, but I'm assuming it was working, right? There's no bug reports about this. And before the GPIO. And if GPIO is not enabled, remember that list can be a semicolon separated list, so you can say that, oh, I want the SOC init to run before GPIO or before I2C or before anything. If there's, then all these constraints will be added to the list, so the list generator will respect that. And if GPIO is not there, it should be fine, but if no, in this my first prototype, if there is no dependence, then I will error because maybe something is wrong, maybe you missed something. The the linker script snippet looks like this. So there's no sorting anymore. It's like a full split thing that was created by the script. And then we build again. Then we have the second step of the build. We build again. And ideally, it should be idempotent with what we have right now. So we should, if we enable this right now, it should just work. I'm not sure it does, because some devices have more than one compatible. I'm not sure how to handle that yet. And right now I'm taking the first one, using. It builds for the things I tried, but maybe it will break something along the way. Also, one thing to mention here that I was experimenting is like you could use that to a specific instance of a device, so a GPIO tree, the third instance. The problem is how to get that information, which one is the tree. Because I first tried to use that number that you get from the DT for instance array, but that number is actually arbitrary. You should not be using that. There's documentation about not using that, so it's not good. I thought about trying to use the ordinal, but then the ordinal is like crazy. Here, the ordinal for the first GPIO is 13, starts. How do you get that? And probably changes with the build too, so not. I thought maybe mapping 0 to the first instance, 1 to the second, but then again, it won't be really good because now is another number to confuse. Maybe I should be using the address. I don't know, that's a question. And this is the link for the PR, if you want to look at it. I created as a draft, so I was kind of hoping no one would look at that because it's a draft, but there are some comments already. So you see, the device module is kind of important, and people are interested in it. So please comment there, and here after, I think I'm fine on time, so we'll have some time to discuss this one. For the not so near future, I also was working, prototyping some stuff, some ideas here, and I wanted a way to notify the application that some devices failed the initialization. You can do that right now. The application can get there's an API call that you get the first device in an array, and then you can loop iterate over it, and check the state and the init result. But that's kind of boring. I wanted to see if, like, could we notify the application, like if the application a simpler API for the application. So the application kind of subscribes to a topic and get this information from there. And we have like a ZBus that does exactly that. So I got curious and I tried. Okay, it seems to work. So I kind of got crazy with this. I kind of found a hammer. So maybe I'm trying to treat everything as a nail here. But then, for instance, for the device, the deferred device, the device that you initialize later, maybe you want to know when the device was initialized. So could we like post on some channel this information? It seems to work, although for this, one idea is like maybe the I2C was initialized later, but now you have like the sensor that's on I2C. You want to initialize it too, but then it will send like a message to the bus. Maybe you are not using subscribers, but listeners, and then the bus will be locked. So I decided to try to have like channels per device. So that can be heavy. So there's some drawbacks. ZBus itself should be light, but maybe having all those channels. But if you don't use them, I can imagine that most of those will be compiled away. ZBus is actually needs like the kernel, so it needs like, I think you use semaphore, so you cannot use that for early stuff, but you probably shouldn't be doing much on the early initialization, so I'm not sure if there's value on telling at the beginning of the application that, oh, something failed, maybe you cannot even respond to that. And the Trojan horse there is because I didn't talk about device notifications on the beginning, so it's kind of like I tried that. I kind of tried to show this in this presentation. But it's also useful for another thing that people are desiring on the Zephyr device model, that is unloading a device, initializing a device. Like there are several use cases. I think that a natural one is if you are like a bootloader entry and you initialize some device to do your stuff, then you want to hand over to the next bootloader entry and you want to deinitialize the device to give like the device in a pristine state to the next entry. That's a reason. Some other reasons are kind of suspicious because I think that they overlap with power management because maybe you're trying to do a poor power management thing. Oh, I'm not using that device, let's initialize it. I'm not sure. And I'm not sure if, even if you are not trying to do something sketchy, how does that interface with power management? The question that I have for you too, like is it independent, is interdependent? Maybe if you want the device to deinitialize, you need to call like some power management thing to turn it off, and then you deinitialize it from Zephyr, from the application. What about dependencies? What like if you take away I2C? What about the sensors that are on top of it? Maybe those dependencies are optional, so shouldn't be a problem. Imagine like in the sensor again, the sensor also is using GPIO to trigger something. If the GPIO is not there, it's fine. We won't trigger anything, but it's still useful. And how we would do that? I mean, one way is going like the power management thing, you have like a device get, device put, so you have count things. But I think that right now we are getting the pointer to the device everywhere on Zephyr and trying to like sanitize that to be like you get things, you put things. It sounds like a really, really big work. I may be wrong here, maybe not going the right direction. And there will be like a long tail of subtle errors. So I'm kind of worried of this. And using the hammer again, maybe we could like notify that the device is going down. And then if you care, like the sensor could subscribe to the I2C channel, got the notification, oh, the I2C is going down now. Oh, maybe I should do something about that. And it seems to work. But of course, I did just some small proof of concept here. I have also a pull request. This is more WIP. It's kind of crazy stuff, but it shows some really small examples of this usage, the device notifications, the device deinitialization. It doesn't do anything. It's just to probe the concept. And again, if you can go there and provide some feedback. This is a draft. I don't think this one had anything, actually. No one cares about device notifications. What is that? But I'm not sure. I didn't look today. So I think that's it from what I wanted to tell to you. And if I'm not mistaken, we have 20 minutes to discuss. So let's talk.
Yes, we do have 20 minutes. So first of all, thank you for your presentation. And the first question or comment?
What is the use case for overriding the priorities that you showed earlier with kconfig and so on? Why do we have to override stuff? We don't do that right now. Yeah.
I'm imagining like an application that added something new and doesn't care about some other thing that's there. I mean, I don't think about the use case. I think more about the possibilities. One thing that some pull requests that I have sent regarding the changing, the tweaking the priorities is usually something else changed. And then for that application, you need to change the priority of something. So I've seen applications that change the priority, like in the kconfig. So I don't want to restrict that possibility. I still want the applications to change something.
Hi, thank you for your presentation on this. Really good. So one thing, if we take what we have today, devices and sysinit. So one thing that's really missing from sysinit and from what I can tell from services as well, is the ability to, from the application side, determine if the service or the sysinit ran successfully. So have you considered a small API, like a services API for querying like devices ready, similar to services ready, that sort of stuff? And seeing that we just now have deferred initialization for devices, how about deferred initialization for services?
Well, starting from the end, I think it makes sense, to be honest. Maybe many of those things are actually moving things from the build time to the runtime to the side. I think this is a trend, and I think that's valid, actually. So, yeah, I think it makes sense. I don't know how, but it's a nice use case. For an API to say if a service did initialize correctly, that's good too. I mean, really, I think that's, I kind of think that right now the sysinit doesn't even have a return code, it returns void, so you wouldn't even know. So yeah, that's a good point. Thank you. Services, yeah.
On the services, what was the thought process on using a string versus kind of how we reference device nodes in other places? And then that opens up however, we have that whole infrastructure, whether it's by label or by, and so forth, so that you could, so I'm just curious as to why you started with a string there for the compatible.
Yeah, I started with a string because in my first iteration, I actually started with a separate file for that. So on the file referencing like the string is like more natural, and it allows to be overridden from like the kconfig or from another file. So that's basically the original idea.
Okay. And then the other one, just as I don't know, I know it's a prototype or it's early right now, but as far as the linker generation, are you doing that in some way to deal with other compilers that aren't GNU linker script?
The first prototype here, I just used something the normal stuff. So yeah, I'm actually curious about like some different tool chains. It may be a problem. I really want to test that.
So before I ask my questions, actually, what Kumar said about the linker scripts, we have an infrastructure in Zephyr that's not very widely used to generate linker scripts from CMake. So instead of hard coding your linker script in GNU LD or LLD or LVM LLD format, you can actually define your linker script in CMake, and then it gets generated. There's a backend that then can generate either LD or, for example, scatter files for the ARMS Clang fork. So that's one option going forward. My questions were, well, actually, they're not questions. They're remarks on the purpose of the init. You asked that you weren't sure that it was. Originally, I remember very well that the first use case that was brought up in the architecture working group and elsewhere was being able to have one single binary that you flash in different boards that have slight variation. So then, when you boot, you decide which revision of the board you're running on, and then deal with the difference in hardware. But I wonder if that particular use case is actually solved with the deferred init, because if you put all the devices that can change in the device tree as deferred, then at that point in the boot process where you know which PCB you're on, you can decide then. The reason some users want a single binary instead of compiling for different revisions of the PCB is that it's the way to test. So not to have one binary that can verify both in development PCBs and in production PCBs without recompiling. So that's for to make sure that nothing else has changed, so to speak. So that was one. But I wonder if that use case is no longer relevant for the init, because we have now deferred init. And then there was another use case that I think is valid still for the init. Is imagine you have a bus, right, I2C, for example, but then one of the lines, sometimes you want to use it as a GPIO. That happens depending on your limitations on pins. So you might want to shut down the peripheral temporarily, use the line as a GPIO, and then bring it up again. That has I've seen that in the wild for sure. Yeah, that's it.
I'm glad it's being recorded.
Yeah. While I'm walking over here, I got a comment on you. You made a comment about the power management and the integration of that, and I think coming in and out of power management states have the same challenges as what you're doing here at the very beginning of initialization order, because you also have the reverse of taking it down in reverse order potentially and stuff like that. So I think as we work through this, we have to keep that part in mind as far as what we're doing.
Regarding that, we also need, Regarding that, I think it's important to note here that, like with power management, at least the way we are doing that right now, I mean, when you go into a lower power state in a device, the device is still there. It's loaded and everything, and then you go in. So this is not the init per se, yeah, because depending who you talk to, this can mean that, hey, I am just going to unload that completely from the memory, in a destructive fashion, and then load it again. This is like, in Linux, removing a module and loading it again, something like that. Yeah. So I'm not sure about the use cases there, but now we have also the loadable extensions. This could be like something to look at. Yeah. My original question, I'm sorry for diversing, is regarding dependencies. What type of dependencies are going to be introducing, and basically in which direction? Because as you mentioned, we have device drivers, we have services. I mean, yesterday Rodrigo was talking about daemons and so on. So what type of dependencies would be possible with this approach, and where do we want to go? And just to emphasize here, what is really the main? I mean, how are we going? Is device tree going to be really the main thing that everything runs around it, or is device tree just going to be one service, let's call it like, or one subsystem that actually provides information into a bigger initialization type of service that we will have?
Yeah, the approach of like getting everything and putting on this topological list to sort, it doesn't really matter from where the information is coming from. I started with the sysinit, the services, but there is actually nothing preventing us from actually getting that from the device tree. The information doesn't need to be there somehow. And I don't see exactly why the limitations, but I mean, you can work around with like instead of before, after or something, but at some point that can be problematic. So I don't think that we should have any constraints there. If you want something to run, if you want to say GPIO runs after something, you should be able to. Right now it's not implemented, but I believe that.
I'll comment on the power management thing, it's like we have a chip that when it goes into the PM mode 3, it loses all settings. It's so annoying. And so, so then you find you're just basically doing the whole initialization again, right? And so it's having a framework to just walk through it again would be pretty useful.
Yeah, so I see a lot of value in what you're talking about here, but one thing you didn't mention that we have today, I've been searching for it while I've been sitting here, but there is a kconfig setting to allow us to get a warning. I think it's a warning. I'm not sure if it's warning or error. Warning or error whenever you basically have priorities out of line. So, for example, you have an I2C device that inits before the I2C bus, and at build time, you're notified of that. I honestly wish that were on by default, but that it's not. And once I found that, I was thrilled because it just is one less thing I have to check myself. What I would like to see is something along these lines, because it's imperfect. It does not take care of things like, GPIO has to be up before I2, something along those lines. So if we had these dependencies in place, defined in place, it'd be nice if we could extend that warning so it was a build time thing. So we could know at build time, you've got things out of order. And that way, low to no impact on code size. And just to comment on something someone else mentioned, they were talking about a service. If you could add an API to query is service ready? My only thought on that is I'd rather see it closer to how devices are today. If you're an I2C device, you check to see, is your bus ready? And I'd rather just see it follow that model. I think services should be same model. Services should be very much like devices, just maybe no hardware involved with a service. I do virtual device drivers already that are basically set in device tree, but there's no hardware associated with them, and I use that model. So that's
Simplifying it with less things, it's always good.
Yeah, so this is actually riffing off of what Anas was just talking about. So the point being, obviously, that traditionally, we've looked at device tree as like a preprocessor that then compiles into a representation that happens to be this older syslin thing. That doesn't need to go away, right? I mean, you can look at this the same way, and the only distinction is, that the thing we're compiling into is now mixed between these new service IDs, whether they be strings or compatibles or whatever, pick whatever that is, and these very strange looking pre-kernel 1, pre-kernel 2 early. I actually just literally had to go and look this stuff up. No one's ever really understood what those things mean, right? I mean, they kind of move around. Early is total voodoo. That happens before Arch kernel init, which is like different architectures do different stuff in there, and it's just a hook where you can do stuff in C. So whether something works in early, nobody really knows. Pre-kernel 1 kind of means before logging. Pre-kernel 2 means after logging, but before, right? So if you just take those moments, Arch kernel init, logging init, device init, right, and just turn those into IDs, the whole thing becomes just a single array of compiled stuff. You don't need to worry about the older API. To the extent of compatibility, right? But we don't need to lose that, right? Like you can look at device tree as a preprocessor on top of this, and it just happens to be that the names in there happen to correspond to device tree if you've enabled it. But I don't know, that's what I got.
I'll say that the early just got added in a little while ago because it used to be the hook that the vendors had to fix any kind of weirdnesses they had with their chip, right? I only know this because I did a presentation several years ago about the whole initialization flow.
Don't use early, just go.
Yeah, don't rely on it.
It's there, you can do it, but you can also include it otherwise.
While I'm walking back, I had one other question that I wrote down. You were talking about on a different topic about notifications. Have you thought about what your latency requirements are for when the notification needs to show up and stuff? Because I think that might dictate which mechanisms you want to use to make those notifications go around.
Yeah, that's a good question. I mean, I don't expect there will be too many notifications going around, and I'm kind of expecting that most of the notifications will actually be using the listener from the bus as kind of write on the EU run. So I don't think that we'll be like subscribing for things and waiting. I'm kind of expecting everything to be a listener.
So, having heard to some of the comments here and your presentation, and having been there when all of this transition happened back in the days in Linux, from CCV init to systemd and the whole fast boot and getting things to boot in 2 seconds and whatever, and people coming up with crazy ideas. But now, obviously, we have systemd on Linux. And when I see some of the concepts here, like with the names, and you're talking about external files and so on. Again, I'm not advocating for creating systemz or whatever. But there are a lot of things, lessons learned, and there's a lot of concepts which can be interesting, at least from this side of things, that we can look at and see how they make sense in our for example, I mean, we were talking earlier, you were talking about external files to define the dependencies. I mean, obviously in systemd we have the units where when it's very basic. We have also the init levels, the pre-kernel, 1, 2, kernel, post, etc. This could be also described as like, milestones in the boot process that different services and device drivers can depend on and so on. And you also talked about the labeling like device drivers with something a little bit more generic so other things can depend on it. So I mean, if you think about it, this is like coming close at least to the idea in terms of how, I mean, the implementation obviously will be different, but I would really encourage us here to start looking into this. I mean, we don't have to reinvent the wheel in terms of Linux is different, but I think there is a lot to learn from there, yeah?
Mm-hmm. Yeah, and one thing about systemd and those things is like they manage things in runtime. So it's not like this is kind of more a static approach, but maybe you want to initialize something later, like you have a crash and you want to start like some URs to send some information there. And that like could be nice if you could like, oh, I need the UART, and then all the dependencies are handled, then you can send the information.
So this question is coming from a place of ignorance, I suppose. But when I want to control the order that my peripherals initialize in and find out if they failed, I write code to do that. And then I come to Zephyr, and I see this auto magic with multi-build steps and no way to know if a particular device failed until there's an update to the ZBus API. And I, as a kind of a lower-end guy, go, what is going on here? Can you give me a little bit about why it's so complex to do something that seems simple to me?
If you had like a callback that on the early initialization, you can, oh, this failed. I mean, there's nothing much there. So we kind of, it was one topic discussed on the deferred initialization indeed. It could be potentially dangerous because what you can do on those early steps using the kernel is kind of limited. And if we kind of start using callbacks that are called on those early steps, you can like shoot yourself on the foot. So that's basically one of the things that we are kind of against having the callbacks at the early steps of the boot. And then you can mess with the word there, basically.
Yeah, and it just to answer kind of at like a higher level, it's just that we're up to thousands of boards now, or over 1,000, I think it is. There's a lot of stuff in there, and if every board's got its own C function that's going to go through and initialize this and initialize this and initialize this, it becomes kind of unmaintainable. I actually was just in a talk about audio DAPM widgets in the Linux kernel, and they have a very similar problem where like every device out there in the world has this big topology that's listed in C code, and yeah, it just turns into a big mess. And so device tree solves that problem.
An application knows the order it needs things to come up in, not the order. Well, yeah, exactly. They're more
Just to continue on that, briefly on that topic, on the complexity. So aside from what Andy just said, I mean, if you had for every single board and combination of kconfig option, imagine just have to have a board file .c with that sequence. I mean, for every board, right? It quickly becomes unmaintainable. That's for sure. But then there's also the fact that you want. Sorry. Yeah, I think so. If it's well written, why not? Yeah, indeed, it is. It's a little bit like why device tree, right? Why device tree? I could have my header files enabling this, but have you tried then combining all support, sort of unified support for all types of boards without device tree? Then it becomes really unmanageable. So this is similar. It's about providing infrastructure that almost every embedded developer needs, but you need to provide it in a way that people can express it, if possible, in a data-oriented way. In this case, with device tree, and then it's verified by the system, and everybody uses the same system. That's the whole point of Zephyr. Otherwise, you do bare metal, but the complexity, in general, long term, is definitely worth it from my point of view, because it gives you all of this. Okay.
Well, that alarm was the end of the time, so let's give him some applause. This is a really well engaging project. And he has a lot of links to PRs, so
Work to do.
so engage there and engage in the meetings, guys. Thank you.
Thank you.